Hello, my dear student. Today we will solve another problem related to inclined plane. So the question is the coefficient of static friction between the 3 kilogram crate and 35-degree inclined shown here is 0.3. So this is the coefficient of static friction. What is the magnitude of the minimum force that must be applied to the crate perpendicular to the inclined to prevent the crate from sliding down? Okay, so first step, we have to draw the free body diagram. Understand the question, draw the free body diagram, all the forces acting on the object. So here we have the inclined surface, and I have force that acting perpendicular to the object, and it prevents the object from sliding down. So the object is supposed to slide down. This is the direction of motion, and this object, I can just redraw this one. I'm going to make it here like this. So this is F. Okay, now I have FG down. So this is FG, and we need to graph X and Y. So here I have X always parallel to the inclined surface and Y perpendicular to X. So this is Y, it should be perpendicular. In the same direction of Y, we have the normal force. So here, this is the normal or reaction force. Now the force of gravity, or Fg, we need to break it down to X and Y component. Since Fg is down, X component, G component is opposite to the normal force. So here I have this one, I'm going to extend it down. So this is the Y component we said before. This angle of inclination, theta, theta here I have 35 is the same as the angle here 35. So this one is going to be cosine Fg, cosine the angle, and X direction, so extend this direction, this will be sine the angle. So Fg sine the angle. Since the direction of motion is down, opposite to the direction of motion, I should have I should have a friction, and the type of friction here is a static friction. The object is not moving. Static, the object is not moving or is about to move. So this one I have Fs. Now after I finish the free body diagram, we determine the direction of motion. We said before, forces in the same direction of motion are positive. Opposite to the direction of motion is negative. But actually, I don't need to put positive and negative because the object is not moving. And since the object is not moving, we need to apply, then we go to the next step, which is applying Newton first or second law. And here we're going to apply Newton first law. So we'll make a table. Okay. We will start this one, X, and here, Y. I'm going to start with Y or X direction. Now in X direction, Newton first law, all the forces in X direction are balanced, and Y direction is the same thing, the forces are balanced. I'm going to start with Y direction, always start with Y direction, because in most cases we have no motion in X direction. Now what are the forces I have here? If we look at the graph, I have Fn up, normal force, is balanced with, I have two arrows down. I have F, which is the applied force, plus Fg cosine the angle. So Fn equals balanced with applied force plus Fg cosine the angle. We need to calculate Fg first. Fg, it's mass times free fall acceleration. the value of M mass is 3 times 9.81, and this we need to calculate it. 3 times 9.81 will be 29.43 in Newton. Okay, so let's plug my values in. I have Fn equals F plus 29.43 cosine 35. So Fn will equal applied force plus 24.1. I'm going to keep this one, this equation, I will call it equation 1. Okay, let's go now to x direction. X direction, forces in x direction, if we look at the graph, we have Fs upward is balanced with Fg sine theta. So Fs here equals Fg sine theta. Fg is 29.43 sine 35. Okay, and this will equal, so Fs equals 16.88 in Newton. Now I can calculate the normal force because I know there is a relationship between normal force and the force of friction, and the equation for the force of friction, Fs, yeah, Fs equals mu s, the coefficient of static friction, times Fn. So I can find Fn. Fn will equal Fs divided by mu s. Fs we've just calculated, which is 16.88 divided by mu s 0.3, and this will equal 56.27 in Newton. Okay, so let's look here. I have Fs, I found out Fs, Fn, and I need to calculate F, so I can substitute the value of the normal force into equation 1 to find the applied force, which is the force that prevent this box from sliding down. So from equation 1, we can write that Fn, which is 56.27, equals F plus 24.1. Take this to the other side and find the value of the applied force. So the value of F will equal 56.27 minus 24.1, and this will equal 32.2 in Newton. And this is how it's done.